Hi there, Pre-Calc students. We're going to once again take a look at an online lesson. This one called Lesson 10.2 on circles. Now the circle is one of the conic sections produced by slicing and dicing a solid cone, as you can see. And thanks to Danny Menzing for volunteering to slice those up for us so we could see the different conic sections. So the one we're looking at today is the circle that's produced by a horizontal cut. Then if we get a little bit slanty, it produces an ellipse, or an oval as it's commonly known. And then we have the hyperbola, which is a straight vertical cut, and the parabola, which again is mostly vertical but a little bit slanty like that. Today we're going to focus on the circle, though, of course. Everyone knows what a circle is. The official definition, as we can see, is that it's a set of all points in a plane that are equidistant from a given point. And of course that given point is called the center of the circle. And the distance from that point to any other point on the circle, you can see our little diagram up there. It's not the diameter but the radius. Now a couple different forms we'll be interested in here with our work with circles. The most important one is called standard form. If we can get an equation in this form, then we can pick out the important points of the conic section. In this case it's the center and the radius. So there you can see what that standard form is. So for instance, if I just gave you an example here, if we did x minus 3 squared plus y plus 2 squared equals 25, could you tell me what the center and the radius is? Well, of course, the center is going to be the point 3, negative 2, negative because of the plus sign in the original equation there, and the radius will be not 25 but 5. Remember, in the equation the radius is always presented as r squared. Unfortunately though, when we see circles, or really quite a few of the conic sections, they're given to us in general form, so they're not factored out nicely so we can see what the key features are. Here's the general form equation of a circle. The x squared plus y squared, as you'd expect, and then we have various coefficients d, e, and f existing as well. Those are constants. Usually they'll be nice values for us to work with. So what we need to do then is try to transform this general form into our standard form equation. Then we can pick out those key features. And in order to do that, we're going to use our old friend, which we abbreviate CTS. And that's going to be completing the square. Now you might remember completing the square was a little bit tricky. We had to employ some algebraic gymnastics to get it in the right form. So we'll look at an example here so you can see how that works exactly. Alright, here's an equation that's in general form. Later on we'll be able to tell that this is a circle and not another kind of conic. So right now let's see if we can pick out the key features of this circle. For instance, we should be able to pick out the center and the radius by the time we're done here. So when we get something in that standard form, we're first of all going to try to group the x's together. So I'm going to say x squared minus 4x. I'm going to leave a little space there, and then I'm going to have the y squared plus 14y, and then I'm going to also leave a little space. I'm going to add that 47 to the other side here. This will allow us to complete the square not only on x but also on y. So if you remember, on completing the square I look at the x's here first, and the number I focus on is the 4. That's that linear term. So if you remember, we can focus on that, I take half of that value. So half of -4, of course, is -2, but then right away I square it. So -2 squared is 4. So I'm going to add 4 right in there. And of course, I'm going to also make sure to add 4 on this side as well. Now taking a look at the y's, well, there my term I look at is the linear term again, the 14y. I take half of that, which is 7. I don't add 7 to each side, but I add 7 squared, which is 49. So I make sure to add that 49 to each side too. Now remember, the whole reason we do that, I'll try to get a different color here for us so we can see this a little bit better. The whole reason we do this, completing the squares, by going through that process, I should now have a perfect square for both my x's and y's. So looking at my x's here, the perfect square will be x minus 2 squared. If I FOIL that out, I'd get x squared minus 4x plus 4. And with the y's, it's going to end up to be y plus 7 squared. Meanwhile, on the right-hand side, when I add all that stuff up, I think I'm going to end up with the number 100. Again, how do I know what numbers go in there? Well, basically, it's always going to be half of that linear term. So now we can take a look at this particular equation. It's now in standard form, and so we can easily see that the center of this circle is going to be at 2, -7, and the radius will be not 100, remember, but the square root of 100, which is 10. Alright, we're going to do another kind of example in class tomorrow, but this gives you a good foundation for some work with circles. So, tally ho.